So at any rate, as you probably followed in your portfolios there, right, I was supposed to go up first. So interesting note to self in the future, bring the memory stick next time with your presentation on it. See, I heard my secretary, but I didn't listen to her. And so at any rate, hopefully I'll do better in the future. According to MapQuest, so I actually had to go back to Greenbelt to actually get the memory stick. So according to MapQuest, travel time is 6 minutes, 3.54 miles. They lie. They don't know DC Metro traffic very well. So at any rate, good afternoon. Hopefully I won't put anybody to sleep with what we're going to talk about here, which is, again, along the lines of more than you imagine, and kind of what is Wallops up to, or what is new at Wallops. So if I go to the next slide, everybody here been to Wallops or know about it? Some do, some don't. Certainly the Orbital Sciences folks would know lately. So we're kind of in two pieces, about 3,000 acres between kind of what we call the main base and then down on the island. The island is almost two pieces, again, kind of a 50-50 mix. And most of what I'll focus on here is a combination of two places and then elsewhere, even on the globe, since a lot of what we do has a tendency to take us where the science is, so they can be pretty far north in the Arctic Circle or can be pretty far south in Antarctica. Next slide, please. So it was founded in 1945, and it was part of NACA. And you know, over the years, 65 of them, as of last year, we've had a little better than 16,000 launches, both suborbital and orbital. The photograph that you're looking at there at the top is actually the very first launch. And the start, or the history there, is that, you know, back in the days before they had wind tunnels, they tried out different aerodynamic shapes on the front end of rockets to try to get the data back. And interestingly enough, right, there's no telemetry back then, so your data came in as long as the wire lasted. And what you can kind of see down there coiled around, and the guy's actually working on some of the final connections, is that spool. So you get a few seconds of data before everything went blank. And then we just celebrated the first launch out of Wallops, space launch, orbital launch, which was 50 years ago in February 1961, which was the Explorer 9. So it's been a part of certainly NACA and NASA history since the very beginning. On the next slide, kind of what we do for the agency is management and implement frequent, quick response, low cost, or as low cost as we can do of them, risk-tolerant missions. Risk-tolerant means we do have failures from time to time. Our running average for sounding rockets and balloons, we try to stay in the 85% range, which, you know, is not palatable certainly to the big science missions that NASA does in other areas. And basically we're kind of an R&D arm. The mission elements, suborbital and small orbital research carriers, research range operations, carrier and operations technology development. And I'll talk a little bit about each of those as we go forward through here. On the next slide, talking about sounding rockets, typically we fly about 20 of those missions annually. We've got roughly 10 vehicle configurations and more come and go depending on what assets we can get our hands on. A lot of the rockets are made of leftover DoD parts. We have 9 worldwide launch sites for our mobile campaigns. We have folks out scouting out in Australia coming up here shortly, and they just went down to Kwajalein for a mission. Well, we've launched in Puerto Rico and a number of areas over the world. Sweden, we had a couple missions out of there in December, and in Poker Flats, we had 2 missions out of there in January. And obviously we support all the major science areas, heliophysics, astrophysics, planetary physics, technology development, and education is a big part of what we do as well. On the next slide, one of the missions that's being integrated right now out at Wallops for a launch this fall out of White Sands comes from Boston University, Dr. Supriya Chakrabarty, and it's called Picture. the Planet Imaging Concept Test Bed using a sounding rocket. And basically a little bit about what it is an extremely lightweight mirror that basically deformable, not unlike what's being built up for James Webb Space Telescope now, only on a much, much smaller scale. Picture it's a collaboration, again, with a number of different entities across the agency and universities, including Boston University, JPL, Goddard, and Charles Stark Draper Laboratories. Kind of switching gears, next slide talks a little bit about our scientific balloons, typically about 14 missions annually. We've got folks right now setting up in Antarctica for a mission coming up here, hopefully around the beginning of April, or maybe ahead of whatever the next planned government shutdown might be. We have these balloons are. This is probably the biggest part of the education in the year that I've been there. These balloons, I'm used to balloons, weather balloons, et cetera, for launch vehicles. You know, we send them up all the time for just finding out what the winds aloft are, et cetera. These are substantially larger, up to 60 million cubic feet. So these are, you know, Astrodome-sized balloons, up to 22 acres of material. So it's a tremendous amount of material that's put together, and they're all hand-built. Suspended loads up to 8,000 pounds, and float altitudes up to 160,000 feet. So the balloon classes, we've got kind of three. There's kind of the 2 to 36 hour duration, which is the one we're setting up for right now down in Australia. The long duration, which is one of those items we're getting to now. We had a pretty successful test in Antarctica here in January, and I've got some video footage coming up. And actually, you can see it in the photograph at the lower portion of this screen here. It's at altitude, so it's a pretty good shot of what that looks like. And those are 40+ days, and then super pressure balloons, which is the latest thing coming up, and those, you know, potentially up to 100 days. We've got some more work to do before we get there, but that's what we're working towards. Worldwide launch sites: Sweden, certainly, Australia, Antarctica, and a couple stateside, which is Palestine, Texas, and Fort Sumner, New Mexico. And again, mainly astrophysics, technology development, and education. I guess the technology development, from a balloon standpoint, sounding rockets are a number of the payloads that fly on the bigger platforms today got a start or got some TRL level improvement as a result of flights maybe they took out of being built up down at Wallops. On the next slide, which talks a little bit about some of the different missions and gives you an idea also the size of these payloads. So over 4 decades, we've had about 30 different spacecraft missions that have been kind of precursors to some of the big science missions that are either planning or coming up shortly or are already up and flying. The one that's not mentioned there is the one in kind of the sunset photo, and that's HASP, which is a high-altitude student platform. And so there's an educational component to what we do on balloons as well. On the next slide, relative to new technologies, the superpressure balloon, we had a good flight in Antarctica here in January, and that came on the heels of a failure that we had a couple years beforehand. Had a material problem, also had some interesting, I guess, things they learned relative to how you lay these things up, relative to the tendons that basically get woven into the balloons as they're being laid up. And then some of the future things we've got going on are an arc second pointer, so we can get some very precision pointing at the base end, the gondola end of the balloon. Test flight again for fall this year, and our future plans are looking at some kind of trajectory control, and that basically would allow us some latitude to fly balloons in a particular area. Right now, for Antarctica, we rely on the reverse cyclonic to set up, usually in the December time frame, and that keeps us more or less on the continent. It just circles us around. With something like this, we may be able to go for a little bit longer and get the scientists a little bit more data. So it's something that we're certainly going to look for as we go forward. The other thing is with these superpressure balloons, the duration, you know, if we can get over 100 days, maybe some desire to control them over overflight areas where maybe we do some mid-latitude type missions and we'd want to avoid big cities, et cetera, or at the point where it's time to bring it down, we want to be able to steer it and bring it down in an area where we know we're not going to have any problems from a safety standpoint. And so the next slide I had is actually a video, and I don't know if you can play the first one or not. Okay, we'll try to do that. And this one is the super pressure balloon that went up here just in January. So the balloon actually you're still looking at all balloon there, all the way down to the point where you see the change in color there, that little knot, that's all balloon. So that will certainly inflate at altitude. And when we call it super pressure balloon, that's a little bit of a misnomer, right? Super pressure in the balloon world is 0.01 psi, so it's not a lot of pressure. So you can imagine a zero pressure balloon has much less. No, it doesn't. The large crane vehicle at the bottom is what we call the launch vehicle, not to be confused with, I guess, what we all know and love as launch vehicles. And then the collar is what deploys off the front end. What's important with balloons, right, is as they lift off from the ground, you want to make sure they don't wrap themselves up and and all the stuff coming out. So they actually collar it partway down, and then they release those as it starts to inflate. So next up, no, not another film. This one actually can go back to the slide presentation. Maybe. Very good. All right, Airborne Science. So currently we've got a group of about, I guess, 15 or 18 folks up in Greenland supporting Operation Icebridge, which is kind of picks up where ISAT left off, and before ISAT 2 gets up is the process here, where we're actually trying to continue the data that would be missed by not having the spacecraft up. At this point, they left middle of March. They've flown 25,000 kilometers or so already, and they actually are up today again, typically about 8 hours a day, again mapping the entire northern latitudes there. They've actually had a couple departures into Alaska, so I mean we've gone it covers a wide area up there. 250 basically flight hours just for the science portion of it alone. And then so they'll be back probably around mid-May is the way it looks right now. On the next slide, something that's picked up quite a bit recently, not so much in the larger platforms, but in the smaller ones, is the unmanned aerial systems. We've got the HS-3 on a Global Hawk coming up here in 2012. It'll be a 5-year program. But we've been doing a fair amount right now with the smaller 14-foot or so sized wingspans for these Viking 300 vehicles. And for those, we typically have flown those off of the island. We've actually got a small runway down on the island. But when we bring in the Global Hawks, we'll be flying those off of the main base. So, we can kind of show you all this as if you ever have an opportunity to get down and take a look at what we've got going on down there. On the next slide, a little bit on small satellites. Most folks are familiar maybe with CubeSats, so not being satisfied with that, and actually taking advantage of kind of the lift capability that we've got with these UAVs, is we've come up with a 6U version. So it's basically a series of kind of the 6 small satellites, 10 centimeters on a side. And we're setting those up right now to fly off of the small UAVs. It basically leaves about 2/3 of the volume available in each of those pods then for the instruments. And we've got a test version of that out there flying right now. And we will have a lot more of it going on in the summer months. Switching gears again, the next slide is the supersonic inflatable aeroshell demonstrator. this kind of falls in with some of what Bobby Braun has talked about in the past, which is his entry, descent, and landing ideas. And so this is a test that will use a combination of some of the balloon technology we've got, some of the rocket technology, again, to speed it up. And we're looking for some flight tests here in the 2012 to 2014 time frame. Right now, looking at flights out of Australia, but they are considering maybe something out of Wallops from a cost standpoint. And so those things are being chewed on a little bit right now. And it's, again, a pretty good collaboration between not only what Goddard's got going on, but certainly JPL is taking a big lead role in this. And we have, I think, the next video up, which is just a short cartoon on on what we think it would look like. Yes, that's the one. So the folks at the Mission Planning Lab put this short video together. So no doubt you've seen a lot of the fantastic work that JPL has done relative to some of the Mars missions in the past. This is just another extension or another approach to also landing larger payloads on the surface there in the future. And I think that's it for that one. And back to the slide presentation. I think I only have 2 more videos, so that hopefully won't tie you up too much longer here. Okay, ORS-1, operational responsive space. So part of what the range does is we're obviously open for business for a lot of other customers, government as well as commercial. And we have the first launch of their ORS payload maybe in the late May time frame. I think right now there's a tie kind of going between TACSAT 4 on the West Coast and ORS-1 being built up right now or integrated down at Wallops. Electrical-optical payload for infrared imaging, and again, shooting for the late May time frame, but we'll see what the DoD decides based on this one in TACSAT 4, and I think they're supposed to decide kind of in the early April time frame on that one. On the next slide is the LADEE mission, Lunar Atmospheric Dust Experiment Explorer. This will be the first lunar mission out of Wallops, and it'll be using a converted Peacekeeper, but in a 5-stage configuration. So Minotaur 5, the 5th stage being the stage that basically gets us into the lunar trajectory. Be pretty interesting to see how this one ends up turning out. We've got a lot of work underway right now with Ames building up the spacecraft, and a lot of the integration working groups that are underway right now to make that a reality. Again, from a budgetary standpoint, this is one certainly that we're watching just to see how that one goes. And if you pull up the next video, just a short clip on what we think that looks like. The interesting part of this mission also is the inclination adjustment will be performed as they fly around the moon. So the spacecraft will actually take care of that aspect of it itself. Thanks. And if you go back to the slide presentation, I think I have just one more item to talk about, and that's what the latest is going on down on the island. Did any of you, by chance, attend the ribbon cutting that was held there about a week ago? Only one, huh? Okay. Well, we got some work to do. Get some folks down there. Quite a transformation, I think, taking place on the island. And Taurus 2 from Orbital Science is going to be the first vehicle to kind of use those facilities. Generically, we're kind of looking at medium-class capability down there. But it's being developed basically to support space station resupply missions. And so we've got about $100 million of funds from both the state of Virginia, federal government, and obviously Orbital Sciences being put in to develop the systems that are down there. Initial flight probably late this year. So the next slide, okay, is the horizontal integration facility. So it's about almost a football field inside, basically set up to do horizontal integration of any vehicles that might come in. The payload portion of it would still be integrated at a separate site and fueled separately, and then be brought in here to be placed on the front end, and the whole vehicle rolls out as one piece, and then it would go up the stand. And I think we might actually have another video there. I think it's the last one, I promise. So the Taurus 2 vehicle right now is a two-stage. First stage being liquid oxygen and kerosene, second stage is solid, and then kind of the last mile solution to hook up with the space station is from their Cygnus, which is a bipropellant. And it'll use berthid method of actually docking. And then I think I have just one more slide, which is a photo of the pad as it sits currently. Still a tremendous amount of work to be done in finishing it up, but we've got a lot of the big items in place. You can kind of see off to the left there the liquid oxygen tank, and then just closer to the floor here on this side of it is the gas farm. So we've got the helium and nitrogen tanks sit in place. Where the water tower is, which is, I guess, the tallest water tower of its kind in the world, is basically set up. Orbital's plan is to do a 30-second hot fire on the pad, and so the water is set up there then for the cooling that would be necessary to take care of that and any of the acoustics. And then just below it, in the foreground, is the RP1 tank. And so the plan is you drive straight out of the HIF, which is out of the picture, and then it will basically drive up the ramp and lift up, not unlike what SpaceX has done in their vehicle down in Florida. But that's the pad currently as it sits today. Again, they're in the process right now of hooking up a lot of the electronics, continuing the plumbing and those kinds of things that go between the tanks on the actual pad. Off to the left of that, you can kind of see the large structures there. The smaller of the two is one of our sounding rocket launch houses. And then the other one is where MLAS was done. I don't know if any folks were familiar with what MLAS was. That launched in '09, but it was a pretty spectacular mission, again, along the lines of the R&D that Wallops does. So I guess I'd, at this point, like to thank you for your time. Certainly want to welcome anyone that has any interest in coming down to Wallops. It's about a 3-hour drive from here. I know, because I do it twice a week, at least for now. But that gives me an opportunity then to listen to the radio a fair amount. And so I tuned in on one this last weekend, which was Prairie Home Companion with Garrison Keillor. So they have these jokes for geeks and things like that that they play. So the one I'll leave you with is, there was once a young man in his youth who professed a desire to become a great writer. When asked to define great, he said, "I want to write stuff that the whole world will read, stuff that people will react to on a truly emotional level, stuff that will make them scream, cry, howl in pain and anger." His dream came true. He now works for Microsoft writing error messages.